So passing of a log file, we tried to do that in a MapReduce program. Okay. So what we did, we tried to run a MapReduce program which will read out the required information in a regular expression, and then it will create a file which is a structured data. Okay. So what we did, we tried to create a mapper. So this mapper will read it based upon a pattern we define, and then it's going to create the output. So the key is going to be the IP address, and the value is going to be all the rest of the stuff that we need, like timestamp and page, HTTP status, bytes, user agent, and all. So this is a mapper, and then we had a driver class. In this driver class, we are just setting what is the name of the job, who is the mapper. So we just set that mapper is CLF mapper, and there is no reducer, so we don't need to set anything. We just set the number of reduced tasks as 0.
So when we don't have a reducer, we set the reducer task to 0. Is that how we do it?
Yes.
Does this happen very often in the real world?
Yeah, I mean, see, like most of the cases where you don't need to aggregate the things, or where we don't need the final result, then we don't need the reducer. Like in our case, so over here we are not aggregating, we are just passing the data and storing it in some format. So we don't need a reducer.
Okay.
Whatever Scoop does, so Scoop pulls up the data from database and stores it on HDFS. We are not reducing anything, right? So it's a mapper on the job. So many of the cases you will find only mapping is required, not. Okay. So
Okay. Makes sense.
that happens quite a lot, that we don't need to reduce the data. So once the mapping is done, we will be getting some data. We'll be getting using those that mapped output for further processing. Okay. Now this is the code we have in this file. We have CLF mapper. Okay. We have the main driver, which is parse block. Now we need to compile this. So for compiling, I need to set the proper class path. Okay. So two of the jar file which is required, we know that it is Hadoop core, Hadoop common, and client core. These are the two jar files required to compile any MapReduce program. Okay. Now this is a sandbox. This is a Hortonworks sandbox. Okay. If you see, this is a Hortonworks sandbox which I started.
So this is not the regular machine that we run?
No, this is not the regular machine that whatever VM I had. That is showing me some issue. Last class we show, right? It was not able to run anything. Right. So that I just kept it aside. I started a virtual box with a VM with the Hortonworks. Right.
Okay. Is this available for free? Can we also use it?
Yeah, you can also use it. All you need to do is simply go and download it. It's very simple, and it makes your life much easier. Okay. Now,
Okay.
what you need to do is simply go to Hortonworks website. No, just say Hortonworks Sandbox download. Okay. And it will take you to the Hadoop download in Hortonworks. So same thing for Hortonworks and Cloudera, both are same, no difference. Okay, but you just have to say Cloudera Sandbox download. And what you need to do is you need to click on download a sandbox. Okay. Then it will ask which image we want. Like so over here, this is the latest one. HTTP 2.4 is the latest one. So download for VirtualBox if we want to run it on VirtualBox. If you want to run it for VMware, just download it. And after download, what you need to do is you have to import the appliance. Right. So once you click on file, click on import the appliance. So wherever it is downloaded, you have to browse that. Like over here, you will find this file after download .obf file. You just have to select this file, say open, and press next, and automatically it will import it. Okay. So it's very simple. Once you download, you will get everything installed. So you don't have to manually install the stuff. Like over here, it comes up with everything. You will get MapReduce, Yarn, Hive, HBase, Pig, Scoop, everything. Zookeeper, Flume, and whatever, Spark, everything is there. Okay,
Okay.
it's a package of all the software we need.
That is pretty awesome.
Yeah, so it's very good for developers to just quick start. Okay, you got everything in this. Now, once we have it, this is I'm using the same. Now over here, since it is not the core Hadoop, so you will find the path of RPMs placed over here and there. Like earlier, we used to go to Hadoop home and then search out for our jar. Over here, you will find everything, but you just need to search around. Like if you go to now, what are the things we need? Like so, we need so I'm the user link. So in the user HDP, so the best thing is just find. So find slash hyphen m. What are the things we need? We need Hadoop common, okay, Hadoop common jar, and it will list out wherever it finds this jar. So we have so many Hadoop common. Okay, now we can use any one of it. I can go to anything is fine. All are same, so I can take any one of it. Let's do this. Again, I can take this. No problem. That's what I will say. Hadoop Java C hyphen CP. This. And one more, the one which I need is Hadoop client core jar. Now which is present in MapReduce client core. I can use this. And then I have to give this. First, I need to compile mapper class, okay, which will give me a class file. Then I need to compile. Over here, I have to append the current folder also because it contains this class file, which is getting used in parse. Alright, so we got both the classes compiled. Come out of it. Create a jar file, jar hyphen cvr, and then let's say I want to say it is a parse log.jar. Yes, we got a jar file. And next step is very simple. The way we run any MapReduce program, we need to have the input file in HTML, which is present over here, Apache log file. Okay. So what we will do, we will say Hadoop jar and then this parser, and name of the class is parse web logs. Okay. It needs two argument input, and let's say I want the output in parsed log. Right. how it looks. My data is parsed. So we'll get this file in a local path. Alright, you say this is the output of my MapReduce program. First one is the key, which is IP address, and rest everything is the value. So my value is again parsed with a tab. So this is the timestamp, this is the page, and then some HTTP status. At the last we have the bot, the agent from where the traffic is coming. Alright, so everything we have. So all these some bots are the one which is coming out from some server. We need to pass all this out. Okay. Now once MapReduce is done, we are done with the some to get the data. So we passed a log file which is kind of a unstructured data, and then we format it out in a some structured form. Okay. Then I want to filter out all unnecessary content in this log file, or unnecessary means all the data which is coming out from the robot traffic. So for this, we'll be making use of a pig, and in pig also we'll see how to do that. So we need to filter out the data, and for that, let's see what we need to do. Okay, so if you come out of this, there is a folder pig. Okay. Now in pig, the program that we need to look out is users and bot.java. Return the bot traffic. So this is the one. Let's download it. And then we do this. Okay. So in pig, what we are saying is load the output of MapReduce program as, so we are defining the column name. So we have IP as a character array, timestamp as a log, page as character, HTTP status, payload size, and user. And these are the things that we have in the output. Okay. Then we are writing a user-defined function is user agent bot. So wherever we have user agent as a bot, and we are passing the user agent, which is the last one. Okay. So filter all by not user agent bot. So this will return if it is bot, then it will return true. Otherwise, it should return a false. So this is a user-defined function that we have to write to filter it out. Filter out all unnecessary bot traffic. Okay. So how to write this? We will make use of a Java user-defined function. Let's go into this program. So what we have over here, this is interesting. Okay. Now if you look, what we are doing, we are writing a class which is extending from filter function. Okay, so filter function is a class in pig which is kind of a base class for all filter related stuff. Okay. Now in this, we are defining a function load blacklist. Okay. Now a load blacklist is function which will load a file in the hash. Okay, and it is kind of a distributed cache. So we discussed about distributed cache. What is a distributed cache? Kind of a lookup data. So whenever we have to use some small data set as a lookup, we can store that data in the RAM of the data node so that my lookup becomes faster. Okay. So since we are using a filter function, I want to store all the blacklisted URLs in a file and use it as a lookup file.
For Dheeraj, I have one quick question. Is there a size specification that we need to keep in mind when we use such a function because it loads up from the RAM?
File specific is it? No.
No, I mean like how big can the file be if you want to use this
Right.
filter function?
So anything which is around, I mean, it should not be greater than the block size.
Greater than the block size. Okay.
Yeah, so ideally it should be lesser than the block size. But see, I mean, memory is a constant, right? So you just have to be careful. Not even greater than the block size. Ideally, it should be in few MBs. Let's say 2 MB, 3 MB. Then we can put that in the RAM. Okay, so just we'll keep one thing in mind that all the data node will be putting this file in the RAM. Right. So if your RAM has only 12 GB of the data, only 12 GB or 16 GB of the RAM, you cannot load a very big file in the RAM. Right. So ideally, it's very small file, 5 to 10 MB, but that should fit up.
Okay, makes sense.
Now, what we are doing, we are taking a set. Okay, we are taking a set of string. Blacklist is a new hash set. Okay. Then, before we do that, okay, so over here there is a function get a cache file. So any file we cache it in the RAM, this get cache file will get all those files. Okay. So we are getting all the files. So what we are doing is this file, which is present in this path / POC blacklist.txt. Okay, I'm naming it after hash. I'm naming it as blacklist. Okay. So whenever I say that you read this blacklist file, okay, it will read it, and then over here, while user ascent is not, while user is equal to in.readline not equal to line, which means as long as the input line is not null, I mean as long as the data is there, I'm adding those URLs into a blacklist. So blacklist is a hash. Okay, blacklist, I'm adding all those user ascent in the blacklist hash. Okay. So what we are doing, we have a file in which we will list out all the blacklisted URL. Okay, and we'll add that in a distributed cache. Now this function will read that data from the memory. Okay, and then it's going to put the content in a hash. It's a Java hash, which is kind of a map. Okay, hash is something which can be used for lookup purpose. Then in the function, exec function is the function in which we define all our core logic of user defined of the UDF. Okay. So if blacklist is null, which means there is blacklist is not defined, we load the blacklist. Okay, so it will load the data in a hash map. Yeah, Prasad, you have some questions? Okay. Alright. Then string. Alright. Then input to this function is a tuple. Okay, so tuple, what is a tuple? A record is a tuple. Okay, one record is a tuple. Okay, so we are taking the input as a tuple and converting it into a string. If blacklist contains this string, okay, so whatever input is coming to this user defined function, we convert it into a string. Now, if the blacklist contains, this blacklist is a hash set which we took from the lookup. So if it contains, it will return true. Otherwise, it will return false. Okay. Now, what it's doing, it is taking the input, comparing it in the lookup file. If the value is found, it will return true, else it will return false. And what we are doing over here, we are saying that you give the user agent and filter all the data which is not returning true. Okay, and then we are storing the data in some output file. Which means we are filtering out all the data which is coming out from a robotic traffic. Alright, let's see. So first I need to have this ready.
Dheeraj, I'm keep getting some feedback noise. Is that from your end?
Feedback?
Yeah, so there is some noise coming in the background.
No. Something. They're getting some noise. No,
It is better now.
okay. So let's do one thing. We will compile this program. Okay. For compiling also we need to have a jar file. Java C will give me error, so I need to have a big jar file like this triple and all that. So we need to have this big. Now let's go to user STP. So we have this big core over here. Right. So all the jar files. Now we were looking into the extracted bundle, but Autonomous has done it. They have created a folder like this in user STP and then the version of STP, and then we have respective folders where we can look out for the jar files. Okay.
Okay.
We have one for pig, hive, all everything, HBase and everything. Okay.
Okay.
So we'll be using this jar file to compile our program. Okay. And it says cannot find writable comparable because writable comparable is part of Hadoop. So we need to get Hadoop also. Let's get Hadoop. So after comparison, we got the class file. Next step is we have to make a jar file out of it. Alright. Okay, so for our case, I need to register this, the path of my YouTube is big channel over here. And then Apache TSB. So this is the output of MapReduce program. Now case it is slash. Okay, so it is into Apache log.txt parsed log. Okay, so I'm going to give this path.
So Apache.tov is not there, right?
Yeah, so okay. Okay, so my output is present in slash parsed log. You see, we have a slash. So this is the path that we give. Right, the part has been it's going to take all the part as this is this and all. Right? So we are loading the input data, and then we are saying you filter this by not is users input, and then store this data into slash POC somewhere. So we'll create this directory as let's say slash POC and no ports. Let's create a directory. And we need one more thing. I need to store the lookup file into HDFS because
Okay.
of here, if you look into this program, it's sitting on form over here like slash POC blacklist.txt. That's why I need to create this slash POC blacklist.txt into HDFS.
Okay.
index.txt, we need to have this entry, Mozilla support. So there is enter entry, and this is the last one. I'm going to put it into HTML. Okay. So big script is completed.
Okay.
You can check the output. Big, we go into big and more codes. So we will plus hyphen plus. Let's go to now output. Let's see the output. Now over here, see there is no, it's all the genuine data that we have. There is no data which contains some boat and all. And if I search for some boat, it's nothing there. So it's all filtered out. And so this way we can use big for filtering purpose. Now once the data is filtered, we can store this data into Hive tables and we can run our queries on top of it.
Queries.
Yeah, and our queries, right? So let's see how we do that. So if you go to POC folder, we have HQL. Okay, this is page view.hql. Let's download it. Alright. So the first thing that we need to do is we have to create a table. Okay, and then load the data into that table. Right?
Okay.
In Hive. So the syntax is very simple. Create table this. You have to define all the column properties. So table delimited field delimited with a tab. Because my output of pig is in a tab, I have to specify estimated by a tab. So let's quickly go to Hive. From here I can type Hive. Then go to Hive show. Alright. So we are into Hive.
Oh, okay.
Let's create a table. Alright, so my table is ready. We have this page view created. Next step is I need to load the data which is output of pig into this table. Right, so where is my pig output? Let's go into that folder. Slash POC and no words. So load data path.
Table name.
Table. Select count. Let's select start page. So we have 500 records.
Okay.
Okay. Now if you see the query, what I give, I just give the folder, right? So if I have, let's say, 100 files, in this folder, everything was set loaded.
What happens when one of the record is not in the correct format? Does that record get dropped, or anything? Will anything after that record get processed, or it just stops over there?
Right. So let's say one record is not in a proper format. Okay, we have one record which just has one column. So it will, that one column will become the first column, and rest every column will become null.
Can you repeat that?
Okay. Now in this, everything is format. I mean, all the data were proper format. Okay. So we had, let's say, table has 5 columns. Okay, and all of my records contain 5 columns, but one of the record contain only 2 columns. Assume. So
Okay.
what will happen? The first 2 columns will get populated, and rest 3 will become null for that record.
Okay. What happens in the other case if there are more number of more data than the columns?
Yeah. So if there are more data than the columns, then only those will be. I mean, let's say first 5 will be taken.
The remaining will be dropped.
Yeah.
Okay. If there is a mismatch in the format, like for example, we are expecting. Say that again.
If you are expecting.
So if if I define the table column as numbers, but there are text in it, what happens then?
Yeah. So that case, it will be all null.
Okay.
That column value will be null. Right. So there will be no case where you will get the exception saying due to the data format issue. It will be all null. If you get some null, you have to go check like why it is null, and then if the expectation is integer, right, and the data is string or something, then you just verify. Right, so
Okay.
you can get some like if it is null, you can get some warning saying expected is integer and the input data found is string kind of. Okay, but
Okay.
it won't drop that record, or it won't give any exception. It will load it with null values.
Okay.
Right? Now, once this is ready, what we need to do is, now this is done. What we'll do, assume I want to run some query and I want to store the data in some folder. Okay, I want to store the result of some query in a file. So Hive supports that. The way we need to do is we have to create an external table. Okay, with the expected.
Okay.
We have to, with whatever output we are expecting. Let's say I want the URL and the number of time it is visited, right, to be stored in some external file. So what I will do, I will create an external table. So create external table is like a folder which has the values as a files. And so create external table. Use PS we are taking a string and use as integer, and then we say row format delimited by.
Tab.
tab. Anything we can give, so let's make it tab. Now over here we have a choice. We can give it comma. We can give it as a comma if I want the data in a CSV format, or we can give a tab also. So anything is fine. Okay, it's up to you. We are seeing lines terminated by /n. Okay, stored as a text file. Now, since it is an external table, I need to specify where my data should go. Okay, because external table is nothing but a folder which contains some files. So I need to
Text file location.
Location is where the data will be going.
Okay.
Stored as a text file, and location is where the data has to be stored. Okay, so we created an external table, so it will create a folder. Now I want the data to be populated from my base table. So what we do, insert into table page view. What are the things I need? I need the page and count of distinct IP. From page view group by page. So we'll be grouping up them by the page, and then we get the count of distinct IPs. And that result will be stored in a file where the location that we have specified.
So even this file actually is running as a MapReduce job.
Yeah, because it's a Hive query, so everything is MapReduce. Alright, so that is done. We can go and check it. We can say select star from page views. For each of the URL, it is giving me how many distinct URLs I have visited. And also I can quit this and I can go to Hadoop Express cat slash POC page view and then part star. Page views. Oh, page underscore views.
POC page view. Page view.
Also, it's stored as a file, which we can take out, and it's a CSV extract. And we use it for other purposes.
So whenever the input file is changed, we need to run the query again to create that, move the data to the external table.
Yeah. So every time an input file is changed, right, we have to run this query to populate the external table.
Okay.
So it won't be automatically done because it's a job which will be calculated. So every time, let's say at the end of the day, we are running this to find out the top visited page. So we can schedule it to run every in the night at some time, right? And then we get the top viewed pages.
Okay. I think this is where my development work is. So in where I'm working, they have jobs that they are running to populate the data into the external tables, and from external data, the external table, we are actually pulling it into our database like Oracle or you know, and we are running our data mart. We have a data mart over here to
Right.
process the data later.
So you are getting the data from Oracle and processing it and storing them in external tables, right?
No, actually, we have log files that are getting created. Hadoop, in Hadoop, those files are just dumped on the Hadoop. Then we have um, the Hive jobs that run to create external tables and populate that data into the external table. From those external tables, we are pulling it into our Oracle database to analyze what kind of customers we have, etc., etc.
But you must be doing something in the external table. Okay, so let's say you have log files. You create an external table to point to those log files. That is correct. You must be running some query to reduce the data.
Yes, yes, we are doing that. Yeah, we are doing that. When we are moving the data into the external files, the query actually, they reduce the data over there.
Yeah, so that is very important. And once the reduced data you have, then you can move on Oracle for different purposes.
Yeah, they actually have a lot of work that they do to mask the SSNs, date of birth, policy numbers, things like that. So,
Right, right, right. So this masking is done in Hive? I don't think so.
they have an algorithm that they don't want to share. So, we have a third-party vendor which we use it for encryption and decryption.
Yeah, that is correct. So all those things happen with third-party tools only.
Yep.
So you will be getting only a masked data in your log files.
When we move it into our Oracle database, we are actually moving the masked data. The masked data we can actually unmask using the process that we have, but we generally never have to actually do it. We just need to make sure we get the correct customer ID, and we are making the joins, and we have various external tables that we process to see what we need.
Right. Okay. Right. So once you have this, what you can do, we can run a scoop job to move the data, because this is a file. Okay, this is a file. This is a folder which contains a file, right? So we can run scoop jobs to move this data into Oracle also. That would be the next step.
Okay.
Let's see what.
Yeah, for this actually they are having it scheduled as a sync sort. They are using it as a sync sort jobs. They are using the sync sort tool to do that as of now.
Okay.
So things are changing. They might do something else at a later point of time.
Okay. All right. Okay. Now there are few things which I have also loaded in this share folder. If you go to study material, and if you go to materials, right? So there's a folder handout materials. Okay, over here there
Okay.
are some good materials for learning purpose like Avro and Hive, counters and MapReduce, MR unit, file formats, indexing, and then the spark. So these are some good useful learning materials which are self-explanatory. You can just go through them. Okay.
Okay.
A spark is something that we'll have a look. Okay, so not today, but tomorrow we'll have a look into the Spark, what is it and what are the features. We'll take some small examples and try to run them.
Okay.
Okay. So let's. So
What happened to the other person? There was one more guy with us, right?
today he said that he got some urgent work, so he has to leave. That's why.
Okay. All right. How many more sessions do we have, Dheeraj?
Spark will be the last one.
Spark will be the last one. So tomorrow is the last session?
Yeah.
During the course of the